Sometimes the way that the nitrate has been formed, especially when it comes to a gut, the septic and manure waste is overlapping. And that's because, the human gut and the pig gut and the cow gut, they're not too terribly different, well, at least when it comes to nitrogen isotopes. So when a project requires that we have an actual source definition, so not just a finger and a tracking, but a real source definition, several non-point sources have appeared, and we're trying to really determine where to start this project, this remediation project, well, we can rely on boron isotope. So now we have a third isotope. So we've used the delta 15N of the nitrate and the O18 of the nitrate to identify whether or not we have something that is sourced from the atmosphere or the water bodies. And then we can also tell how enriched our delta 15N value is. And then we could take it one step further with the addition of boron isotopes. The boron isotope is very useful because unlike the nitrate isotope, it's conservative. It's not participating in many reactions, is present and unchanging. And what that allows us to do is compare these delta 15N values to our boron 11 values, and that can really help us determine where sources are. So we see here on this graph, very similar to our O18 delta 15N, we have our nitrogen on the X, and then our boron on the Y. And we see that there's really not too much overlap with the exception of some fertilizers, but we would expect rainfall to be pretty enriched. So, what I wanted to show here was that, when there are cases where source identification is critical, we'll just go ahead and employ the use of a conservative isotope, and we can sort out those problems really well. So just, it's kind of fun stuff to share.